In this video, we're going to talk about the end behavior of polynomials. So what's happening when I look really far to the left on the x-axis and really far to the right on the x-axis, and what happens with that polynomial. So let's start off with a couple of kind of simple ones. How about x squared? So when I think about x squared, let's think about how I would graph that. So if I were to plug in 0 on the x-axis, then 0 squared is just 0. And how about 1? 1 squared is just 1, 2 squared is 4, 1, 2, 3, 4, and then so on. So 3 squared is 9, really high there. And when I go to the left, when I plug in, say, -1 squared is 1, -2 squared is 4, and that's why we get this parabolic shape that looks like this, okay? And so if I was going to talk about end behavior, then what I'm thinking about here is when I look to the left on the x-axis. So when I plug in numbers like -2, -3, -4, -5, -6, and I ask myself, what's happening when I plug in those numbers far to the left? Well, as I plug in those numbers going to the left, then the graph is going up high. It's going up towards positive infinity on the y-axis. So I might describe this behavior as the x's get very small, the y values get very large. Or as my x's approach negative infinity, then my y values will approach positive infinity. They're going to, 5, 6, 7, 8, 9, all the way up. And then when I look to the right, at the end behavior to the right, I'm thinking about, well, what happens when I plug in these values over here? So when I plug in 1, I get 1, 2, I get 4, 3, I get 9, 4, I get 16. So what happens as I plug in bigger and bigger x values to the right? Well, I get bigger and bigger y values going up, okay? Okay, so now what I'm going to do next is let's go ahead and put these into notation. So let's think about this. So what was I saying there? I said as I plug in x values really far to the left, or as I plug in x's that approach negative infinity, and so what this says right here is as my x values on the x-axis go to negative infinity, then what happens with my y values? Or I might say f of x, because f of x is really the same as y. So as my x's approach negative infinity, well, my y values, or my f of x, it goes up, it approaches infinity. Okay, so one more time. This says, as x's approach negative infinity, as my x's get small, my f of x, or my y values, get really big. They go to positive infinity. Okay, and that's one of the end behaviors there. Okay, so let's talk about the next one. As my x's get really big, or go to the right, my y values, it looks like, also get really big. So I'm going to say as the x goes to the right, or approaches big numbers, 5, 6, 7, 8, 9, 10, 100, 1,000, approaches infinity, then what happens with my y values? Well, my y values, or the graph, is going to go up at that point. So that's also going to approach positive infinity. Okay, so as my x's go to infinity, as my x values, I plug them in bigger and bigger and bigger. What happens to my y values? Well, they approach infinity. So my y values go up and up and up. Okay, let's go ahead and maybe look at the opposite here. So now how about, let's say, let's make my f of x be, say, negative x squared. Okay, so you may know that that's just going to flip everything. So when I plug in 0, 0 squared is 0, and then -0 is just 0. But then when I plug in 1, I get 1 squared, but then -1. 2 squared is 4, but then -4. And kind of the same thing over here is going to happen. So I've got this downward facing thing. Okay, let's see if we can go ahead and come up with my end behavior here. So I want to say that, let me just put my x-axis on here. So here's my x-axis, right? So I want to say that as I look to the left, as the x values go towards negative numbers, bigger and bigger, so towards negative infinity, what happens with my y values? Well, on the graph, when I look further to the left, my y values get smaller and smaller and smaller. So if I was going to put this into notation here, I'm going to say as my x's go to the left, as my x's approach negative infinity, then what happens to my y values, or what happens to my f of x? Well, my f of x also approaches negative infinity. Okay, so let's just compare that with the graph here again. So as my x values get small, as I look to the left, then my y values will also go down. My y values will also go down. Okay? Okay, let's go ahead and do the other side of it now. So now what I'm going to do is I'm going to say, okay, how about when I look to the right? How about as my x's get bigger and bigger and bigger? What's the trend? And all we can see, is 2, 3, 4, and kind of what's happening here. But really, I'm thinking as I continue this trend, as I continue out to 10, 100, 1,000, a million, what would happen? So I'm going to say, as my x's get bigger and bigger to the right, or approach infinity, what's going to happen with my y values? Okay, so as I look further and further to the right, what's happening with the y values of the graph? Are they going up or down? Well, it's going down when I look to the right. Okay, so that means my f of x is going to approach negative infinity. Okay, so one more time real quick. As my x's go to the right, the f of x's or the y's go down. The f of x's or the y's go down. So there were some examples of x squared and negative x squared, which are both even functions. And let's now go ahead and consider some odd functions. So let's consider the kind of simplest version here. So let's do x cubed. So I'm going to go f of x is equal to x cubed. And let's go ahead and take a look here. So again, if this is my x-axis and this is my y-axis, let's take a look at what's going to happen. So if I plug in 0, 0 times 0 times 0, or 0 cubed is 0. If I plug in 1, 1 cubed is 1. If I plug in 2, 2 cubed is 8. So maybe, kind of up there. And when I plug in negative 1 times negative 1 times negative 1 is negative 1. Okay, negative 2, I would get negative 8. So it's going to kind of shoot down to the bottom there. Okay, so that's going to be my general shape of x cubed. Okay, let's talk about end behavior here. So for my end behavior, let's think about what happens as x goes to the left. So as x approaches, say, negative infinity. Okay, so what is happening? So on my x-axis here, when I look in the negatives as x goes to the left, where is the graph going? So in the end, or the end behavior, when I look to the left, what's the graph doing? It's going down. So I'm going to say, as my x's go to the left, then my y values, or my f of x values, go down. They go towards negative infinity. Okay? Let's go ahead and take a look at the other direction here. So if I'm going to look to the right now, if I'm going to look to the right, so I'm going to say, as my x's go to the right, or approach infinity, then what's going to happen to my graph, or my y values, or my f of x values? So when I look to the right, what's happening to the graph? Well, it's going up. It's going up and up and up. So my f of x values are going to approach positive infinity. Okay, okay, now let's go ahead and kind of look at the opposite here. So let's look at f of x is equal to negative x cubed. Okay. And again, that's just going to kind of flip this thing around. So when I plug in 0, I get 0 cubed, that's 0, and then negative 0 is just 0. Instead of 1, I'm going to get negative 1, and everything is just going to be pretty much flipped. Okay? Okay, slightly off there, but the general shape is going to be the same. Okay, so here's my graph. Okay, let's go ahead and take a look at maybe when I look at x values that go to the left. Okay, so when I look, let me put my x-axis on here, we should know, but there's my x-axis, here's my y, right? So when I look to the left, so as x values go negative and more and more and more negative, then what's happening with the y values, or what's happening with the graph? Well, as I look to the left, my f of x values are going higher and higher and higher. So my f of x, I'm going to keep it the same color there, so my f of x is going to approach positive infinity. Okay? Okay, let's go ahead and take a look at the other side now. So the other side, I guess that would be going right. So let's take a look at as x values approach positive infinity. So as my x's go further and further and further to the right, what's happening to the graph there? Well, I guess it's going down. So that means that as I look to the right, my f of x values are going down, so they are approaching negative infinity. So one more time here, as my x values go to the right, my f of x values, or the graph, goes down. So these are really the only 4 options that we totally need to understand, and we can kind of extrapolate out anything else just from these 4 options. So let's take a look at the left side, these even functions. And if I had, say, a different example that was maybe x to the 4th, and then it could have some other stuff there, maybe, I don't know, like 3x to the 3rd, and then plus 4x, or anything else. But as long as it is an even function, so x to the 4th, its degree, its highest power is even, then it's an even function. And what I'm going to look at here is the leading coefficient positive or negative? Well, if it's a positive x to the 4th, then its end behavior is going to match up with positive x squared. So I know that when I look to the left, it's going to be going up, and when I look to the right, it's going to be going up. And then it may, do some other kind of interesting things in the middle, but what's important is if it's a positive even function, then its end behavior will be the same. Look to the left, it goes up. Look to the right, it goes up. Look to the left, it goes up. Look to the right, it goes up. Okay, let's kind of compare that with maybe an even negative function. So what if I had something maybe like a negative x to the 6th, and then, it could be plus anything else, so I don't know, maybe 8x to the 4th plus 22 or anything like that. Okay, but the important thing is if it's an even function, so the highest power is even, 2 here, highest power is even, 6 here, and a negative leading coefficient, then the end behavior is going to match this model. So I know if it's negative and even, goes down to the left and down to the right. Okay, and then other things, I could be doing some interesting things here, and just kind of a look into the future. The higher the degree is, the more kind of bumps it's going to have. But the end behavior is all we're concerned about for right now. Okay, let's go ahead and take a look at some odd functions. So when I'm looking at x cubed, a positive x cubed, that's going to be similar in behavior to any positive odd function. So maybe like, say, x to the 5th, and then it could be plus anything here, 4x plus 2 or something. So then the thing I want to compare is, well, this is an odd function with a positive coefficient. So I know the end behavior is going to be the same. So I know to the left, it goes down, and to the right, it goes up. And all I'm doing is kind of choosing my, using my little cheat code right here. So x cubed, I know, goes down to the left and up to the right. So if it's a positive odd, down to the left and up to the right. And then some other stuff could happen in the middle here. I don't totally know, but that's okay, because all I want is the end behavior. Okay, let's take a look at this last possibility here of a negative odd function. Okay, so I could compare that with anything here. So any negative odd function, so maybe negative x to the 7th, and I don't know, plus 26 x squared. Okay, the rest doesn't matter. As long as the highest degree is odd, then it will match here, and the leading coefficient is negative, then it will match here. So I'm just going to use my little cheat code right here, and it says, well, look to the left, and it goes up, look to the right, and it goes down. So I'm going to look to the left, and it's going to go up, look to the right, it's going to go down, and some other funky things are going to happen in the middle, but my end behavior is going to be the same, okay? And so from there, I can just use my notation and go ahead and write out that end behavior.